it looks quite similar. One here, the other one, and yep, it looks working. It looks working well. Hey guys, welcome to Louis Python. Today in this video, I'm going to share with you how to train up a model, and the models can help you sort out the stock tickers by profitability performance. So you can automate the process to list out all the tickers and look at the performance in one hub. So in this video, there's two sessions. The first part is the data pre-processing, the preparation. And as you can see, I already prepared the data set. And the second part will be the focus today, how to train a model and identify the opportunities, initialize the test and save the model and load the trained model and run a test data set. Before the video starts, please remember to subscribe our channel and turn on notification. You can receive our latest video in time. This is very supportive. Thank you for supporting as always. So let's get started. The first part is we need to configure some settings and import some modules. For example, we need request Google Colab because we've used external APIs to fetch the income statement data set. Because as mentioned earlier, we will look at the profitability from each ticker. So income statement is required. Here is the token access to the API. Here headers is for authenticates our API ownership. And then we need pandas because we need pandas to manipulate the data from external parties. Sometimes, or maybe usually, the data set is not in the format as we expect. We would like to restructure the data as well. And then is the terminology. As mentioned earlier, we look at the profitability. So there are three metrics will be our focus and train the model up to analyze for us. The first one is gross profit, and then EBITDA, and the last one would be net income. Secondly, in terms of look at single year, we will focus on momentum trends over the past 4 years. That means we look at the YOY. That makes sense. I think in terms of the long-term investment, we are not looking at just single year performance from a ticker. And this is the algorithm methodologies to recalculate the score. For example, if YOY was up, we +1. Or conversely, if the YOY was negative, that means losing money. The ticker was not earning money last year. We will -1. And at the end, after we have summed up the ticker's value, we come up with a final number. And each number represents the performance of the momentum trend from each ticker. Okay, so this is the context. I think this requires importance to walk you guys through a little bit because that is the algorithm will be our objective. Which this is the way we train the model up, and the model which will be saved in the future and help us to automatically predict and sort the tickers out by profitability based on our expectation, right? Okay, let's move forward to the next session is, start training the model. First thing, we need to import some module as well. We will use Scikit Learn model / import train test split. Okay. We will split the data set into training data set and test data set. Let me elaborate more in details in a moment why we need to split the data set. This is a very important concept. Whatever model now you're training up, whatever algorithms now you're using. Y train, Y test. And train test speed. Okay, this is our data thing. And then we will use the gross profit change trend and also the EBITDA change trend as the features. Okay, as the features. And then final result. The net income trend would be our label or record object. And test size, we use for 3, random stay 0. 0. 1 this. Okay. And we also need to be processing the string and the xtest data frame as well. So Scikit Learn import processing string and processing normalize. The reason we need to import this module to pre-process the data because any machine learning algorithm, basically they handle the data in a standardized format. It is a 3D or 2D array, and now xstring and xtest is a data frame data type. So basically the purpose of this module and this code is to transforms the data frame into the standardized formats of an array. The machine learning algorithms can understand what is the data sets there and then train the data up and build a model. This is the Scikit Learn. I copy this as well. No. And test. Okay. So we can try to print this out and look at the outcome. Okay, right? This is an array compared to our original string xtest is a data frame. And the next part will be identifies the most popular clustering quantity. So the purpose of clustering the data set is because we like to split out, or we can say breaking down the code into different segmentation. And each segmentation represents one nature of the performance. For example, one good represents from the takers, they perform pretty well over the past 4 years. This is one good we can cluster up, and we can apply to different strategies compared to other groups, to this group only. So this is the purpose. But the question is, at the moment, we don't know how many clustering we should have in terms of the model training. How many clustering group we should tell the machine learning model help us to solve in the future. So this step is to test and find out the answer. Okay. First, we also need to import the module. First, KMeans and Scikit Learn matrix. So low ret score. Low ret score. We can test a clustering group range, for example, 2 to A. Because 2 to A, I need to fill up 2 to 9 within a range. And create 2 empty lists. One empty list is the fit. The other is score. Okay. Maybe I change this one into big capital. Okay. And model KMeans. the few arguments we have to fill up some value based on the K-means documentation. For example, n underlying clusters. This is the clustering group quantity we're going to set here. We have to fill in. The other one is random state. I fill in 0. For more details about what's the argument for, please go to the Scikit Learn's web pages and have a look. I'm not going to go deep dive in this video. But I would to add some value sample here for your reference and fit string long fits append model and score silhouette score string no model label metric. Let's print the score out. Okay. Oh, it's the typo. I miss S here. And the other typo? Yeah. I'm a typo man. Okay. Here it comes up with a list, and in the list there are 1, 2, 3, 4, 7 score. So technically, higher score represents better. Lower score represents maybe okay, but worse stands to a score sitting on the higher position. So that implies we should breaking down into a clustering group, right, in terms of this answer. But for my experience, sometimes we are not able to 100% follow up the score here because it really depends on the size of data set now you're using. Now we are using 300 tickets, right? I'm not going to break down into too small by each group because you don't want us to have one segmentation. They just have 10 or 50 instances. You prefer instead a clustering group might have 100 or maybe in my case, a total quantity of the tickets are 300, at least 880, right, from each clustering group. So I might prefer this one, and which means I break down into 4 groups. 4 segmentation from the tickers. We are using 300. Okay. And after we identify the clustering group quantity, here the next step we would like to have a test. Oh, maybe I show you. Maybe I show the let me show you the this one. I want to visualize the current clustering group into a scatter charter, into a scatter chart. So here is a SNS and then scatter plot data. I use string x. I use, for example, go change profit, and then the y is the EBITDA change trend, and here would be the feed because now we are using this one. So fill in 2 labels. Let us see how it looks like. Oh, it should be fits. Okay. Ooh. Okay, perfect. So basically now we already been able to see some patterns, the clustering group pattern. Obviously, here is one group, right? Here's one group. And here's the other, and this is the last one. So totally there are 4 groups, and each purple color represents one clustering group or one segmentation. Good, not bad. And start the testing, initialize the testing. Okay. I was to create a function first, so get clusters. The data thing here, and cluster, create a column, KMeans, and so I copy here. I don't want us to Y once again. Copy here, and then initial one, and fit the label. Okay. This is the function. And I try to test using this function and using the clustering value. We just look at the score and select 4 and test the training data set we just prepared earlier. So results get clusters. Maybe I try the final result first instead of training data and see how it's going. Okay. Great. And I also tried to, because now we have 4 segmentations, right? I tried to print out the segmentation and have a briefly track what momentum trends each clustering group represent. So for example, here I print this cluster equal to 0. 1, 0, 1, 2, 3. KMeans already help us to use the number represents each segmentation. And I copy, paste here, and just change the value. Let us see. Let's print them out and see once again. Okay. This is the first one, cluster 0. It looks like, yeah, fluctuate, right? Kind of. Maybe I mark here, fluctuate, fat, and EBITDA. And your net income downward. Okay. And the second group would be the 1. So obviously this is the downward. Momentum trend is downward. So I mark down here is downward. And next one is the cluster 2. It's quite fat, no change. Okay. I just say fat. And the last one, cluster 3, sorry. Yeah, obviously, momentum trend of upward. Great. already have for segmentation. Good. And so basically now we have the clustering value, and we also use the original data frame set to test the result. It looks making sense, right? So we are able to save the model. We save this model. We will save the model using joblib. Maybe save the model. KMeans, this is the model we built. Again, cluster, we use 4. Random state, we use 0. And initial. And initial here is if you want to customize the array, you are able to set the centroids here, but I'm not going to go deep dive as well here today. Maybe I shoot the other videos to elaborate the samples, how to use this part for K-means algorithm model training. It is very useful. And K-means fit, xtrain, long. We will use xtrain long here because, as mentioned earlier, we should use the standardized format for training the model up. So we use the xtrain long here. And I click print. So this is the model we already trained up. And now is the time, maybe I able to show you once again, use this model. Where does the scatter chart look similar to the one we just used the original data frame, right? Xtrain. I can use the same one I show you here. Let me go back a little bit, and the one wants to write it again. This one is the same. And then I go back. Okay. What is different would be here. Because now we already saved them. We already trained the model up using the xtrain norm. We directly use the model's label here. Labels. And let us see how it looks like. K-means is not defined. Oh, I'm sorry, typo. So this is why I say myself is a typo man. I always make typo in coding and programming. This is not a good habit. I need to improve myself. Okay, it looks quite similar. One here, the other one, and yep. It looks working. It looks working well. And we can save it. So just mention we will use the joblib. Technically, there are two main types of the library for us to save model. One is the Pickle, the other is joblib. I prefer joblib because if you use Pickle, you will find out some of the platforms out there, like saying Hugging Face, they are not welcoming Pickles because there are quite a lot of gobs out there. Pickles has a lot of bugs and virus. It is very easily create some spam on the platform. So most of the platform out there, not most, yeah, some of the platform. I'm not, want us to hurting the brand image of Pickle, but it's just the gossip. You guys can have a try as well. So I use the joblib, and the models we just name the variable is K-means, right? And I say K-means model 1 joblib. I print wanted. So here is the model, and the model will be saved here, yeah, on Google Colab. Okay, it's done. And the last step is to load the model we just trained and then run the data set to have a look. Rather, now if we put into some new set of data we never use ever, what would be the result look like? Whether it's similar to the result we just test above or is different. If the result is similar, that means the model is working, right? So let me have a test. First thing first, load the model. Drop lib load, and the model is the name. Here, load the model, and I try to use the model to predict the X test. So I elaborate here. I just mentioned why we need to split down the data set, the data thing, into X train and X test. It's because after you have trained up the model using the X train data set, you want us to test it, right? And you don't want us to fetch the others, long related data sets out there compared to the original one you are using, like since the 500, SP500. So here I can reuse the original one, but the rest of the data that we don't use to train up our model. So this is why it's very important. We need to split down the data set, data thing into train and test. So let us print this out to have a look. Predictions. Great. A list of the K-means clustering value, 0s to 3. And let me have a look what data now X-test have. It's a data frame. Okay. So we also list the net income change trend and also prox the predictions clustering needs we just generated here, right? To create a completed data frame. For test rather, the training model can predict the value in a correct way using a new data set. So let me create here. Net income, just copy here, and Y test, and also the X test is the cluster. I use this prediction, and I print the X test again. Perfect. Right? And the last step is to compare now the new data things from X-test and the new set of data, whether looks similar to the one we generated using the X-trains data set, right? So we can try to visualize the data. I go back and copy the C-bond because here, but just change a little bit. I use X-test data thing instead of X-train or final result. And I use predictions instead using the model we use above and see how it looks like. Great. Similar, right? Okay, this is pretty much the day, and this is the model we trained for sort this out, sort the tickers out by profitability. So I hope you guys like it, and I will see you next time.